Welcome back. Today we're going to talk about consensus algorithms in cryptocurrencies. What are they? To better help us understand them. Consensus algorithms, they are fundamental components of cryptocurrencies that enable distributed networks of computers to agree on the validity of transactions and maintain a consistent and tamper-resistant ledger. These algorithms play a crucial role in ensuring the security, reliability, and decentralization of a blockchain-based system. So in traditional financial systems, there's a central authority, such as a bank, which verifies and validates transactions. In cryptocurrencies, they operate on decentralized networks, where multiple nodes, which are computers, the computers work together to achieve consensus on the state of the ledger. This decentralized approach eliminates the need for a central authority and provides greater transparency and censorship resistance. There are several consensus algorithms used in cryptocurrencies. Each has its own unique approach to achieving consensus. Some of these we explored yesterday, so I'm going to lightly touch on them. The first is proof of work. This is the consensus algorithm that powers Bitcoin. It's the first and most well-known cryptocurrency. That's where a lot of power is needed to solve complex mathematical puzzles. The first miner to solve the puzzle adds a new block to the transaction. So that goes onto the blockchain and receives a reward in the form of a newly minted coin. The second one we talked about is proof of stake. This is an alternative consensus algorithm that aims to address energy consumption. So it really addresses the consumption of the proof of work, which uses Bitcoin has, as well as the scalability issues associated with proof of work. Instead of miners, proof of stake relies on validators who stake a certain amount of their cryptocurrency as collateral. The probability of a validator being chosen to create the next block is determined by the amount they have staked. Proof of stake reduces the computational requirements, as a block creation is based on ownership rather than computational power, making it more energy efficient. The next one is delegated proof of stake, which is DPoS. It's a variation of proof of stake where token holders vote for a limited number of delegates to validate transactions and produce blocks. These delegates are responsible for maintaining the network's operations and securing consensus. DPoS aims to increase transaction speed by allowing a smaller number of trusted nodes to validate transactions on behalf of the network, resulting in faster block confirmation times. So you can see there's some like an evolution of consensus algorithms in cryptocurrency, and they seem to be getting more energy efficient, faster. The last one we're going to talk about is PBFT, Practical Byzantine Fault Tolerance. That is a consensus algorithm designed for permissioned blockchains where the network participants are known and trusted. PBFT works by establishing a consensus among a set of nodes known as replicas, even if a portion of these nodes are malicious or faulty. It requires 2/3 majority of replicas to agree on the order and validity of transactions before they are added to the blockchain. PBFT offers fast transaction finality but relies on a fixed set of validators, which limits its decentralization. So these are just a few examples of the consensus algorithms in cryptocurrencies. They're probably the top four that are used. Each algorithm has its own trade-offs in terms of security, scalability, decentralization, and energy efficiency. So the choice of which consensus algorithm depends on the specific requirements and the goals on the cryptocurrency project.